This is my third video about this formative that we did on functions. And in the first video, we went through all of the key features of this graph over here, talking about that. And then in the second video, we went over these problems here, which are about evaluating this particular function. And now I'm going to turn it over and talk about problem number 4. It says the function p takes a real number as input and subtracts 7, takes the positive square root, and then outputs the reciprocal of the result. And students had some difficulty remembering what a reciprocal was or how to take the reciprocal of something. And so I want to make sure that we understand that. That's a pretty important idea. And remember, the other time where this came up for us was when we were finding the slopes of perpendicular lines. If I graph a line in slope-intercept form, it's very easy to just identify the slope. Imagine that the slope of a line was 2. And then if I want to find the slope of a perpendicular line, I need to take the negative reciprocal, or sometimes we say the opposite reciprocal of that. Well, to take the reciprocal of a number is really, I'm going to turn it into a fraction like that, and then we're just switching the numerator and denominator. So this becomes 1/2. Now, if this was really a slope of a perpendicular slope of, the relationship between the slopes of perpendicular lines, then I would have to have a negative sign in here also. But there's nothing about a negative reciprocal here. It's just the reciprocal. And so this is how you take the reciprocal of a number. Really, what you're really doing is you're dividing 1 by that number. And so if I wanted to take the reciprocal of x, then I would simply take 1 over x. So when I think about what to do for this function, I'm going to first, it says the function p takes a real number as input. Well, here's a function called p, and I'm just going to use x to represent that real number that I'm putting in. And so we get p of x. And I'm going to take that value of x, subtract 7, take the positive square root, and then output the reciprocal of the result. So I know I'm going to have a reciprocal of the square root of x minus 7, my input minus 7. So let's just walk through that one more time. Imagine I gave you a value of x. It takes that number, subtracts 7, takes the positive square root, and then outputs the reciprocal of that positive square root of the difference between x and 7. And so there we go. That's our function rule. Next, we're asked, find x such that p of x equals 1 over 3. Well, I know that p of x is equal to 1 over the square root of x minus 7. And I'm asked to find the value of x that's going to give me this. So from here, I just noticed that what I really want is if this denominator equals 3 and the numerator is 1, then this denominator also has to be equal to 3 because the numerator over here is 1. So these have to be equal. So I can say that the square root of x minus 7 equals 3. And from here, I have an equation. I can just use my algebraic techniques to solve it. I'm going to square both sides. When I square the left-hand side, I just left with the x minus 7, and I get 9. And then from here, I can just add 7 to both sides, and I get x equals 16. So if I put 16 into this thing, I should get 1/3 out. And we could just verify that. No reason in just leaving it. Let's think it through. 16 minus 7 is 9. The positive square root of 9 is 3, and then the reciprocal of 3, that's 1 over 3, 1/3. So it checks out. I will, let's see, write the domain of P using set notation. Okay, here we go. So imagine any function in terms of x, let's begin by imagining that I could put any possible real number into this function. So that's where I start. And I think, like, when I look at this function, I'm going to start by saying, like, okay, well, x is a real number. It's going to be, let's imagine that it could be any possible real number, and then let's figure out which ones we're not really allowed to use. So the first thing I'm going to notice is that if I'm taking the square root of a real number, it has to be greater than or equal to 0. So I'm going to say the square root of x minus 7, I'm sorry, let me just get rid of the square root. What I know is whatever I'm taking the square root of, which is x minus 7, has to be greater than or equal to 0. And I can simplify this a little bit by saying then x must be greater than or equal to 7. Okay, and I'll put a little note here because we only can take the square root of non-negative numbers. Okay. And so that's one important constraint that I have on my domain. If I tried to put a number of a value of x like 6, which is not greater than or equal to 7, then I would end up with a square root of -1 here, which, some of you know that's we can do that actually. That gives us an imaginary number, but we're only dealing with real inputs and outputs in this unit and in this class so far, really. So that's one important constraint that I have on my domain. But there's another one. It's because I can't divide by 0. And so I also know that the square root of x minus 7 cannot equal 0. So you'll notice, really, I could simplify my life by just getting rid of this less than or equal to business. But let's just carry this through. If we know that the only value of x that would cause this expression to equal 0 is 7. So x is also not equal to 7. And the reason is because we can't divide by 0. Divide by 0. So that together, these two things give me the restrictions on my domain. And for our unit on functions, those are the only two restrictions on domains that we're considering right now. If you have an equation and you're asked, hey, what's the domain of this function, you are going to first make sure, okay, well, I'm not taking the square root of anything. I can't take the square root of a negative number, and I can't divide by 0. And if you account for those two things together, then you have correctly, you will get the proper domain. So notice, really, the condition that I want to meet considering both of these things is that x has to be greater than 7. Not equal to, just greater than. So I'll use my set notation to write that down. Okay, x is a member of the real numbers such that x is greater than 7. And that's the set notation that I'm looking for right there.